Billions of years ago, the universe started as a tiny point of light, energy, and particles. It expanded rapidly, cooled, and gave rise to atoms. These atoms clustered into stars and galaxies, laying the foundation for everything we know today, including our own planet. Hi, my name is Sofia Giannattasio, and this is my crash course video on stellar evolution. Today, we're diving into the birth, life, and death of stars. Let's get started. Birth. Stage 1. Interstellar cloud. Everything starts with an interstellar cloud, also known as a nebula. This massive cloud of gas and dust begins to contract, often triggered by an external event like a shock wave from a nearby supernova. As it contracts, the cloud fragments into smaller pieces, and each fragment is capable of forming a star. Stage 2. Collapsing cloud fragments. Next, these individual cloud fragments continue to collapse. As the density increases, the fragments stop breaking apart, and the materials start concentrating into a denser core. Stage 3. Fragmentation ceases. At this point, the interior of the cloud fragment heats up to about 10,000 Kelvin. Fragmentation ends, and all the material focuses on forming a single object, the beginnings of a star. Stage 4. Protostar. Now the star becomes a protostar. It is a hot, glowing ball of gas that appears on the HR diagram for the very first time. While it's starting to look like a star, it is not in equilibrium yet. It is still contracting and heating up, and any energy it emits comes from gravitational collapse. Meanwhile, the early stages of planetary formation are happening in the surrounding disk of material. Stage 5. Protostar evolution. As the protostar continues to heat up, its brightness, or luminosity, begins to decrease. It's on its way to becoming a fully fledged star, but it's not quite there yet. Stage 6. A newborn star. When the core reaches a scorching 10 million Kelvin, nuclear fusion begins. Hydrogen atoms smash together to form helium, releasing a massive amount of energy. A star is born. The main sequence. But there's one final step before the birth is over. The star continues contracting until it achieves hydrostatic equilibrium, a balance between the inward pull of gravity and the outward push of pressure from its hot core. Once this balance is reached, the star enters the main sequence, where it now spends the next 90% of its life. Life. Now that our star is in the main sequence, it spends most of its life steadily fusing hydrogen into helium in its core. This fusion process releases enormous amounts of energy, which radiates out into the space, and it gives the star its brightness. For smaller stars, like red dwarfs, this stage can last tens of billions of years. Massive stars, however, burn through their fuel much faster, sometimes in just a few million years. As the star ages, the hydrogen in its core starts running out. When this happens, the balance between gravity and pressure is disrupted. The core contracts under its gravity, heating up as it does, while the outer layers expand. This expansion causes the star to transform into a red giant. For massive stars, this process is even more extreme, turning them into supergiants. During this phase, the star becomes larger and brighter, but it's also nearing the end of its life. For low to medium mass stars, like our sun, helium fusion begins in the core. Helium atoms fuse into heavier elements like carbon and oxygen, and this phase is relatively short-lived compared to the main sequence. The star's outer layers may pulsate and shed materials into space, creating a beautiful shell of gas around the star known as a planetary nebula. Massive stars, however, experience even more dramatic changes. Their cores become hot enough to fuse heavier and heavier elements, forming layers like an onion, with each layer fusing a different element. This process continues until the core is mostly iron, which marks the end of fusion because iron doesn't release energy when it fuses. At this point, the star's life is about to end in a spectacular way. During the life of a star, it also influences its surroundings. Solar winds and radiation from massive stars can trigger new waves of star formation in nearby clouds. Death. The death of a star depends on its mass, and there are two main pathways, one for smaller stars and another for more massive ones. Low to medium mass stars. For stars like our Sun, the end is relatively peaceful. After the red giant phase, the star's outer layers drift away, forming a glowing planetary nebula. What remains is the hot, about the size of Earth, teaspoon of white dwarf material weighing tons. Over billions of years, the white dwarf cools and fades into a black dwarf, essentially a cold, dark remnant of what was once a shining star. High mass stars. For massive stars, the end is more violent. When the sun is mostly iron, it can no longer sustain fusion. Gravity takes over, causing the core to collapse in a fraction of a second. This collapse releases an enormous amount of energy, triggering a supernova explosion. A supernova is one of the most powerful events in the universe, briefly outshining entire galaxies and scattering heavy elements like gold and uranium into space. These elements will eventually become part of new stars, planets, and even life. What's left after supernova depends on the mass of the original star. If the core's mass is less than about 3 times the sun's mass, it becomes a neutron star. A neutron star is incredibly dense. A sugar cube-sized amount of neutron star material would weigh as much as a mountain. Some neutron stars spin rapidly and emit beams of radiation, becoming pulsars. It's one of the most precise natural clocks in the universe. If the core is more massive than 3 solar masses, the result is a black hole. Black holes are regions of space where gravity is so strong that not even light can escape. They're mysterious and fascinating objects that continue to captivate scientists and the public alike. Conclusion. So there you have it, the incredible journey of a star, from a collapsing cloud of gas to its eventual death. Stars are the universe's engines, creating the elements that make up everything around us, including ourselves. Every atom in your body was forged in the heart of a star. From the peaceful fade of a white dwarf to the violent birth of black holes, stars shape the cosmos and make life possible. Thanks for watching, and I'll see you next time on Crash Course Stellar Evolution.